Hello students, today I am going to cover up threads in operating system. This topic will include definition of threads, category of threads, difference between process and thread, what are the advantages or disadvantages of the thread, how we will come to know a thread uh, is different from a process, and along with that a real life example of the thread. So firstly, covering the definition. A traditional process has a single thread, means a general process that is executing. If it does not refer to the parallelism, in that case, it will contain only a single thread. The thread is a independent or the basic unit of a process. The idea is to achieve the parallelism by dividing the process into the multiple threads. Means in general, it is assumed a process has a single thread, but when we want to achieve the parallelism, so we can create the multiple thread within a process. The thread is a basic unit of the CPU utilization. That means it increases the CPU utilization. It comprises a thread ID and a program counter register set and a stack. How this we will discuss in the next slide. Is how a thread is identified. Thread is identified by its ID within a process. It shares other it shares with other thread belonging to the same process its code section, data section, and other operating system resources such as file and signals. Means thread also shares some of the part of the process, that is the data section, code section, and some special information. Here it is a process. This process has a single thread. So there is a dedicated registers, stacks, code section, data section, and files to this thread. While here is a multiple thread process, means a process may have the multiple number of threads. So in that case, it will contains the uh, stack register with each thread. Here thread 1, it is a thread 1, thread 2, and thread 3. It has its own stack register, while code, data, and files are shared among the different threads. Here, one process, one thread model. Here, one process, but it has the multiple threads. Here, multiple process, one thread per process model, and along with this, here is the multiple process, multiple threads per process. So these are the basically pictorial representation of a thread, how it shares the code, data, and file section. So example is browser. In a browser, we can open the multiple tabs. So each tab has a different thread. The MS Word uses the multiple thread, one thread for text formatting, another thread for process input, etc. Along with this, there is a one of the most popular example, which is uh, the media player. In when we are watching a movie, we see the slide bar gets increases, the video frames also changes, the time remaining also changes continuously. So VLC is a process in which we are watching the movie. There are number of threads created within that process. So each thread is given a to a particular sub process through a thread. So one thread is given to the slide bar, another thread is given to the uh, basically frames, picture frames, third for the time remaining, and so on. Thread components. Thread basically contains three basic components: program counter, register set, and stack space. So these are the three basic components. Here we have seen the shown the basically stack and registers. These are the two components because each uh, program counter contains the address of next instruction which is going to execute. So each thread there must be a program counter associated with it so that whenever the thread is going to process one instruction, so another instruction must be stored before the execution of that particular thread so that the continuation will maintain means continuity will be maintained and there will be no lag of time. Advantage of multi-threading: it is economical. It is economical as they share the same process resources. There is no need of the separate resource for a thread, and it takes lesser time to create a thread. Resource sharing, as we have discussed, it is economical by because it shares the same resources. It allows the thread to share the resources like data, memory, files, etc. Therefore, an application can have the multiple thread within the same address space. Responsiveness. It increases the responsiveness to the user as it allows the program to continue running even if a part of is performing a lengthy operation or the block. Means the maybe possible the picture is not playing, it may get stopped, but it may be possible the slide bar is changing or the time remaining is changing. Means thread may response, may be possible one thread is going is halted, but another thread may response. Scalability. It increases the parallelism on multiple CPU machine. It enhances the performance of multiprocessor machines. Means when there are multiple processors are used within a single motherboard means tightly coupled machine. So parallelism achievement is very fast. CPU utilization. It makes the CPU resources better. Now, there are two type of the spaces for a process. First one is the user space and second one is the kernel space. User space. It is a set of the location where the normal user process runs, that is everything other than the kernel. The role of the kernel is to manage the application running in this space from messing with other and the machine. Means whenever a process is running, there it is using two type of spaces. First one is the user space and second one is the kernel space. So when a process need to interact with the hardware, so it will belong to the kernel space. Otherwise, it will run always in the user space. So here, this is the user space and this is the kernel space. While kernel spaces, it is the location where the code of the kernel is stored and execute under. Means kernel level code residing in the kernel space and it is always executed by the kernel. Category of the thread. So there are two type of the thread: user level thread and kernel level thread. As we have discussed, user level space, user space and kernel space. So Yeah, user level threads always run in the user space and kernel level threads always run in the kernel space. User level threads can be defined as all the codes and the data structure of the library exist in user space. Invoke function in the API results in the location function call in the user space, not as a system call. Means user level threads basically creates and it uses the it created using the local function call and it uses the libraries, while kernel level threads uses the system calls. All code and data structure for the existing library exist in the kernel space. Invoking a function in the API typically results a system call to the kernel. System call. System call basically is a request to the operating system to perform some specific task. For example, in C language, there is read function, write function. So it internally calls the a system call. For example, write system call. There is a write system call. Write system calls takes the some argument from the user level functions. For example, which is the location, how many bytes it has to read, in which mode it want to read or write the operation, something like that one. So user level threads are there and kernel level threads are there. So here is a thread library that residing in the user space and kernel level uh, system calls residing in the kernel space. So here are the example of the pure user level. Here user level, here the pure kernel level threads are there. Here is the kernel combined space for the user level as well as the kernel level. Now, difference between threads means categorization, user level and kernel level. User level threads are easy to implement while kernel level threads are difficult to implement. It recognizes by the user level process, it is recognized by the operating system. It is implementation of the user level thread is easy while it is a little bit complicated. Context switching in the user level thread takes lesser amount of time while kernel level thread switching takes more time. Context switching requires no hardware support, while there is a need of the hardware support. If one user level thread perform blocking operation, the entire process will be blocked. Means if any of the thread get blocked, the entire process will get blocked. While in case of the kernel level, if one of the kernel thread is perform blocking operation, then other thread can continue its execution. Means process will continue its execution. User level threads are designed as a dependent process. Means when one is blocked, the all remaining threads will be treated as the blocked state in the blocked state, while kernel level threads are designed as an independent thread. Means execution of the one thread does not affect the another one. Example of the user level threads are the Java thread. Um, it is very easy to create the threads in the Java uh, and portable operating system interface threads, while the example of the kernel level threads are the Windows and Solaris threads. Now, the question may be arise, what is the difference between process and thread? So here are the some listed difference that I have mentioned. Process is a heavyweight resource. Thread is a lightweight processes taking lesser number of resources than a process. Process switching needs interaction with the operating system. Thread does not require interaction with the operating system. In multiple processing environment, each process execute the same code, but it's has its own memory and resource file. While here While thread shares some of the parts and the rest of the part as an independent. Means the thread shares the list of open files, code, etc. If one process is blocked, no other process can execute until the first process is unblocked. While if one thread is blocked and waiting, the second thread in the same can in the same task can run. Each process uses same code and has its own memory. All threads shares the files and the child processes. The multiple process of the multiple process each process operate independently to each other while threads shares or exchange the data in the data space. Now, advantage of thread over the process. Responsiveness means thread responds much faster than the process. If a process is divided into the multiple threads, if one thread completes its execution, then another output will be immediately returned. Then its output immediately returns. Faster context switching when a process switch from when processors switch from one process to another process, it takes time because it has to perform a lots of operation that such as saving the all information of the currently process which is executing, and then after uh, loading the another process into the registers, so it is taking the lots of time. While in case of threads, the context switching takes lesser amount of the time because most of the information is shared among the threads. Efficient utilization of the multiprocessor system. Multiple threads in a single process can be scheduled multiple threads on multiple processors. Means each processor can be associated with a single thread. This will make process execution faster. Resource sharing. Resource like code, data, and files can be shared among all the threads within a process, as we have already discussed. Communication. Communication between multiple threads is easier as they shares the common address space. Means most of the information is shared by the threads, such as code, data, or list of open files, etc. Now, the question maybe arises here: what are the advantages of the user level threads? What are the advantages of the kernel level threads? What are the advantages or disadvantages of the user level threads or the kernel level threads? So these can be asked during the examination. So you must prepare such type of question. This is from my side. Thank you.